Okay, this is the key for how to do these problems. So um, there's basically two types of random variables. You have a discrete random variable and you have a continuous random variable. A discrete random variable is when you know how many outcomes there are. So you could read the problem and they're saying, okay, the number of red lights that this driver encounters. So there's four, it seems there's probably 4 lights on this road, or 3 lights on this road. This means that he doesn't hit any of them. He hits one of them. He hits 2 of them. He hits 3 of them. This is called a discrete random variable. The reason why it's a discrete random variable is because you could see there's 4 possibilities. And there's a gap between the 0 and the 1 and the 1 and the 2 and the 2 and the 3. Whenever you get these and they start asking for the mean and the standard deviation, okay, there's formulas for them, but you could find these on your calculator, but you should be comfortable with this one. It's 0 times the probability plus the next possibility times that probability, and you keep adding until you get to the last one. This is how you find the mean, but really the way you'd probably do it, since they want the standard deviation also, and that's a more tricky formula, you're going to put this in L1 and this in L2 and do a stat calc number 1. And once we get the data in there, I'll show you how that works. So the way that you get to your data is you do stat, the way you get to your list, stat, enter. And I'll just go ahead and clear these things out. Okay, so I'm going to put 0, 1, 2, and 3 in there. And then you want to put the probabilities over here. So see, the 0 doesn't happen that much. 0.18. The 1 is more impactful than the 0. The 2 is more impactful than the 3, than the 1. And the 4 is the most. This is a skewed left distribution. Because if you graph these things, it's the peaks on the right and it's falling to the left. So 4, 6, 3, 2. Okay, so once we're here, you're going to hit stat, calc, and 1. Now, if you just run it right now, if I just hit enter right now and calculate, this is not the answer. What this is doing is just doing 0 plus 1 plus 2 plus 3 and dividing it by 4. But 3 has a lot more weight than the 0. So if you add everybody up and divide by 4, everybody has the same weight. Okay? So what you need to do is do stat calc 1, and to account for the frequencies, you need to put the 2. You can see it right here, down here on the 2. Go to the 2 and it's color coded, second, 2. Now this is going to find the average with that. So the average is 2.2, 0.87. 2.2, 0.87. 2.2, 0.87. So that's the answer. That's how you get it. Stat calc 1, X list is going to be L1, and your frequency is going to be wherever you put those frequencies. That's how you do number 1. Okay. This question was missed more than I thought it was going to get missed, and some people did just read it funny. But whenever you get these questions, see, there's 2 types of random variables. You have discrete and you have continuous. So the random variable is the thing that you're measuring. Okay? They're measuring the weight, how much the baby weighs. There's an infinite number of possibilities, so this is continuous. This is a continuous random variable because there's an infinite number of weights, an infinite. So these are going to be on a curve, but we have to know what the shape of the curve is, and they tell you it's normal. So whenever you see this normal, you should almost get a little happy because you know that it's going to be a pretty straightforward problem. Okay, now we just have to attack the mean and standard deviation and find out what they want. We could shade what they want. We could do a normal CDF. So they said, oh, the average is 3,300. What's the standard deviation? Just get in the habit of putting the standard deviation up here. Sometimes you have to find it, sometimes they give it to you. They gave it to us here. Okay, which of the following is the closest to the probability will not be categorized, will not be low birth? Well, what's low birth? Low birth is less than 2,500. So this is 2,500. This is low birth weight. So if this is low birth weight and they say not low birth weight, then you're trying to find this region over here. You're trying to find that shade. And the way you do that is you're going to go normal CDF. Now we have the lower. If you have an order calculator, this is going to be the order that you put everything in. And you still want to label it. Your upper, you just want to put a big number, humongous number in there. Then you have the mean, 3,300, and then you have the standard deviation at 375. The way you get there is you go second vars. It's a distribution. Go to number 2. I'm just putting these things in. 0.984. 0.984. Some of you all found this side by accident. Okay, so you have a random variable. It's right skewed with a mean of 2 and standard deviation of 10. The random variable B. Okay, so what you have to know about random variables is 1 plus 3a. So we have a multiplication process and addition process. The mean of the new variable, which will be called mean of B, is going to go through both processes. So whatever the mean of A is, let's get rid of that. Let's call the mean of A. The mean of A is 2. So the new mean is going to be 1 plus 3 times 2. The mean will go through the entire process, but the standard deviation will go through the multiplying process. So what's the, it's going to go through the multiplying process, so 3 times 10, but we do not add the 1. So it would be 30. So it's 7 and 30. Measures of variability do not get added. Everything gets multiplied. Okay, businessman commute to work. Okay, this is his commute to work. He's going to walk, get on a bus, then he has to take a train. They're independent of each other. Okay, so to get the mean, see the total time traveled, you have to think. The walk-in's random, riding the bus is random, and taking the train is random. So you technically have 3 random variables. The total time is going to be the total time for all 3 of these. Okay, so these are the total time is combining 3 random variables. This is combining. And time is continuous. Now you don't have to worry about the continuous here, you just have to know how to find the mean. So to find the mean of the total time, you just add up the means. It's just going to be 5 plus 30 plus 40, which is 75. So I know it's either going to be this one, it's going to be this one, or it's going to be this one. And to find the standard deviations don't add. They don't add. Variances add. So then you're like, well, what's the variance? The variance is the standard deviation squared. So what you need to do is you need to take the standard deviation of W and square it. Then you need to take the standard deviation of the time it takes to ride and square it. Then you need to take the standard deviation of the train and you need to square it. Then you need to add them all. And once you get the sum of all these, This is the variance. So the sum of all these three numbers is the variance. When you get done, you have to take the square root of it to get it back down to standard deviation. So it's going to be 2 squared plus 5 squared plus 6 squared. Okay, so 29 plus 36. Actually, I'll just do it on the calculator. Let me do it. 4 plus 25 plus 36 square rooted. That's going to be your standard deviation. Two squared is 4. 5 squared is 25. 6 squared is 36. Those are allowed to add. So 65 is the variance. If we take the square root of that, we get 8.06. 8.06. 8.06. Okay? So whenever you're combining random variables, this is always going to be your formula. Okay. So they're going to track the attendance for each student absence from school. X is the number of days absent in a week for a randomly selected student. Okay? So if you pick one person, they have a 68% chance of being there every day. They have a 17% chance of being absent one day. This is the chance. So what's the probability that a selected student is absent at most? At most means not more than 2. Was this person, 2 or more? Is this more than 2? It can't be more than 2. It can't be above 2. Has to be 2 or less absences. Okay. Does this person have 2 or less absences? Yes. Does this person have 2 or less absences? Yes. Does this person have 2 or less absences? Yes. You literally just add those 3 numbers. That's all you have to do. Actually, a lot of people miss this question, which is a little surprising. Maybe it was the way that it was asked. I'm not really sure. But it's not those 3. You just add these 3 things up and you get 0.95. Okay, this is probably the hardest question that there was. So you have the July and you have August. And these are all the homes. If we randomly pick a household in July, okay, we could get their utility bill. This is what their utility cost is. We randomly pick a day here in August. This is the cost. So this is the cost of the utility bill. So, okay, for the same city, distribution of cost should be normal. Okay. Assume J are independent. If one household is selected in July and August, what is the probability that July's bill will be more than August's bill? So this is what you do. You say J, and you do A. You say, what's the probability that July will be more than August? So that means July was more than August. So then you set this up as a probability. What's the probability that J is bigger than A? Now, to make this a little easier, so we could see, because we're gonna have a graph of differences. Because how would you know which one was more than the other one? You have to subtract them. You have to get July and subtract. So this is the random variable that we're dealing with. It's the July minus the August. That's how you tell who's more than the other one. You would subtract them. So if you subtract A on this side and subtract A on this side, this left side would be J minus A greater than, and then A minus A is 0. So I need to find out the probability that J minus A is greater than 0. Well, the nice thing is this is normal and this is normal. So the difference is normal. So this is a graph of the differences. So these are your J minus A's. So if we find the mean and the standard deviation of J minus A, then we could find this probability. Just use a normal CDF. So we have to say, what is the average of J minus A? When you're combining random variables, you subtract their means. So this is going to be, what's July? That's 469 minus 498. which comes out to be negative 29. That means that January is $29 less than August on average. What's the standard deviation of J minus A? It's the same formula we just did on this page. On here, it's the same formula. Standard deviations don't add, standard deviations don't subtract. Variances don't subtract. Variances add. It's always variances add. So you need to say, okay, well, 58 squared, that's variance. And you do 73 squared, that's variance. And even though this is subtract, we always add here. You do the variance and you do that. So this is going to be the square root of 58 squared plus 73 squared. Now I'm not even going to pay attention to this number. I'm not going to find it because they didn't ask for it. They say, what's the probability that J minus A is greater than 0? Well, these are your J minus A's. Okay, well, this is negative 29 on a number line. 0 is over here somewhere. Draw a line to the top, and you're trying to find this shade right here. On this side, J is greater than A. It'd have to be positive, right? It'd have to be positive. Like, if J was like 500, which it could be, and what happens if August is like 475? What's J minus A? 25, which is over here somewhere. Now, it's not likely this is going to happen, but it could happen. That's one possible J minus A. There's an infinite number of J minus A's, so it's continuous. Okay, so how do we do this? Normal CDF. Your lower is going to be 0. Your upper, you just need to pick a number really far from 0. J cannot be this much bigger than A. The mean is negative 29. And the standard deviation, I'm not even going to figure it out because then you're going to get round off error. I'm just going to put this right in here. 58 squared plus 73 squared. And then this will give me that probability right there. So second, bars, number 2. Got 0 as my lower. My upper is something really big. My mean, negative 29. My standard deviation, I'm going to do square root. See, there's a square root. And then 58 squared plus, not minus, what's the other one? 73 squared. Unclose it. Now I have no round off error. Enter and enter and enter. 0.378. 0.378. 0.378. Okay. That was by far probably the most tricky one on the test. Okay. 5 friends each enter a pre-sale lottery. You can just pause and read it. Let T be the number of the 5 friends who are selected to win the lottery. Okay. How many friends could win the lottery? It might be 0, it might be 1, it might be 2, it might be 3, it might be 4, it might be 5. This is a discrete random variable. Okay? There's a 25% chance. So which one is the least likely to happen? Which one has the smallest probability? Well, what does this mean right here? The number of the 5 friends who are selected in the lottery. There's a 25% chance to be selected in the lottery. So what's the chance that all 5 are going to get selected? It's 0.25 to the 5th. This is not likely. This is not likely. It's very small. You don't have to find all these probabilities. You just have to know, like, what's the chance that they all get selected? 0.25 to the 5th. What's the chance that none of them get selected? That's 0.75 to the 5th. This is way smaller. This is very, 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 very small. This is, if we look at it, it could be a binomial. The first friend's either going to get selected or not. This is yes or no. The second friend, same thing, yes or no. Everybody has a 25% chance. It's a binomial. But this is super, super unlikely. Hopefully that just came naturally to you. Okay, probability that you have a twin is 0.03. This person has 50 patients that are pregnant. They're independent. What is the probability exactly for? So you have to recognize this is a binomial. I mean, you have to recognize this is a binomial. Okay, it's like 0, 1, 2. This x is the, did they give us, they didn't define the random variable, but the random variable is how many of these 50 are going to be pregnant. So x would be like the number of, not how many are pregnant, they're all pregnant. How many, the number of twins in 50 pregnant females. That's what it is. It could be 0. None of them are pregnant. 1, 2, 3, 4, 5. They might all be pregnant. I mean, it's not very, very unlikely if there's only a 3% chance of having a twin. Sorry, they are all pregnant. They might all have twins. This is the number that have twins. So I'm literally looking for this one. That's what I'm looking for. So the way you do that is you have to say, okay, well, how many twins have to be pregnant? Well, 4 of them do. 4 have to be pregnant. So that's 0.03 to the 4. How many need to be not pregnant? 0.97 to the, how many are there? It'd be 46. Now you have to know how many ways this could happen. So that'd be there's 50 females that choose 4. So that's how you do it. This is it. It's a binomial. So second, it's a distribution. It's just like a normal CDF. You just have to learn how to use your calculator. Oh no, we're not doing that way. We're doing it a different way. Sorry. Okay, so to do this, you're going to hit, I have a more fancy calculator here, so you go math, over to probability, go to NCR, boom, 50. 50 means we have 50 pregnant females. How many do we want them to be pregnant? We want exactly 4. This is going to tell you how many ways. This is going to tell you how many ways you could have 4 pregnant and the rest not pregnant. It's a lot of ways, 230,000 ways that you could have this times 0.03. That's a chance that they're pregnant. How many do we want? 4. Okay, now those are 4 pregnant. How many do we want to have twins? Sorry. How many do we want not to have twins? We want 0.97. How many of these do we want? If there's 50 and 4 have twins, then 46 do not have twins. I need to raise that to a power. So this is how many ways you could have 4 twins and 46 non-twins. This is chance of having a twin. There's 4 of them. This is a chance you don't have a twin to the 46. This is your answer. 50, exactly 4.046. Feels like something was off from the thing, but exactly 4 of her patients are pregnant with twins. That has to be right, because I don't think I made a mistake. Okay, so it's 0.046. Okay, now I didn't teach this to a few of my classes, but some of them I did, were the difference between like a PDF and a CDF. A PDF will find any random variable probability that you want. Sorry, if it's binomial. A binomial PDF will find an exact number. So we have 50 pregnant females. There's a 3% chance of having a twin, and we want 4. So this should give me the same answer if I didn't make a mistake. So these are the same answers. This is the formula way. That's the calculator way. Okay, this problem was a little tricky too, but this is another binomial. So we have 10 people that are going to do this thing. They're going to get blindfolded. They're going to test 3 cups of water. One of the cups will contain a dye, but they're not going to know. So now, what's the probability they're going to drink? They're going to drink from all three of them. What's the probability that they correctly identify it? Assume will correctly identify. What's the chance that this is the first person? The first person's just like da da da. He tries that, tries that, tries that. What's the chance he guesses it correctly? Okay, assuming he cannot taste the food dye. The probability that he is correct is 1 out of 3. So that's your probability. Every person has a 1 out of 3 because they're assuming they cannot taste the dye, so they're just guessing. We have 10 people, so this is a binomial. This is what the thing means. 10, 1/3. X is going to be the number who correctly identify. This is out of the 10. How many correctly identify? It could be 0, 1, 2, 4, 5, 6, 7, 8, 9, and 10. So this is a discrete random variable because there's 11 possibilities. Since you could see how many possibilities there are and there's gaps between every possibility, that's called a discrete, and it's going to fall in a table. Now since it's a binomial, it passes the Benz test. You literally could find every single one of these if you wanted to, but it just takes too long. But if you have the time, find every one, because then the question is going to be easily found, because it says what's the probability that at least 6 identify it. So you're trying to find this probability right here. Let me make it look a little better. You're trying to find all those probabilities, so I could kind of separate it. I could separate it. I'll change the color. Now in class, I'm building like histograms to kind of show it, because you can see it a little bit better with the histogram. You expect 1/3 of them. 1/3 of 10 would be around 3. So this would be like 0, 1, 2, 3, 4, 5, 6, 7. And every probability that you put here is a bar up here on this graph. So we expect 10 out of 3 because there's a 10/3 chance. So that's like 3 and 1/3. So this is going to be kind of big. And then it's going to fall this way. And it's going to fall this way. I don't know if it's perfect, but that's what it's going to look like. This graph's going to be a little skewed to the right. So what you're trying to do is probably 6 or higher. You're trying to figure out what all these probabilities are, which is the right side of the graph. But for a binomial, we don't have something to give us the right side. It'll only give us the left side. So the calculator will fill this stuff out. It'll find this for me. It'll find the left side. Okay, that's a binom. So I'm going to do it by colors. Binom, CDF. Then you have trials. Oh, well, there was 10 people. What was the chance? 1/3. Now this is the tricky part. This thing right here. Since I'm in this color, if whatever number you put here in a CDF is going to find that number and everybody below it. Okay, so when you put this 5 right here, it's giving you this, all that already added up. Okay, but I don't want that. I want 6 or higher. So you have to do 1 minus that. Okay, 1 minus that will give you what you want. So you have to learn how to use the calculator to trick it. Okay, if not, run that NC formula for all of these and add them together. And with practice, you guys could get good at this stuff. I mean, you just have to practice. Look at an example and practice it, practice it, practice. And it'll start becoming second nature to you. So this is going to be 1 minus. Okay, now I need to go to my distributions, second distribution. I'm just going to hit the up button. Okay, trials. What do we want? There's 10 people. What's the chance anybody gets it right? 1/3. And you go 5 here. 5. Enter. Paste. 1 minus. There you go. This is going to give me 6 and above. 0.077. 0.077. There you go. That one could be kind of tricky too, but once you get used to it, it's not too bad. Okay, she needs to order a certain almond flour. 10% of stores have them. She's going to randomly call stores until one has the flour she needs. So S is the number of stores. Kathy's going to keep calling until she gets it. So what this means is that the 8th store is the first to have the flour. So this is called a geometric. Okay, well, what happened on the first 7? See, that's the first call, second call, third call, fourth call, fifth call, sixth call, seventh call. Here you go. She stops. They're saying stop. So this one must have had the flour. What was the chance that this one had it? 0.1. What's the chance the first one didn't have it? These did not have the flour. That's why she keeps calling. Because she has it. She has the flour. She doesn't have to call anymore. This person didn't have it. It's 0.9. 0.9. All these are 0.9. So there's 7 0.9s and 1.1. That's it. That's how you do it. It's when the geometrics are easier than binomials. Binomials, there's a lot to it. Geometrics, just only one way. Fail, 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 fail. Succeed. That's how it works. Okay, there's 7 0.9s and 1.1. 0.04048. Okay, so hopefully this was helpful, and hopefully you're starting to get an idea that you'll have to keep up with the homework, or if you try to wait and cram all this stuff at the end, it's very, very, very confusing, and this stuff could catch up and get you. So you have to put the time in as you go. And if you don't get a homework question, you have to come in early, or you have to send it and remind and set up a time to figure out how you do these problems. Okay? All right.